Hey everyone, welcome back. This is another video discussing the Ultra Instinct prototype rover version 2.0. In this video, we're going to be talking about a different part of the project that I've been working on, and that is being able to control the rover using a web server. And now there's a couple different ways to do this, and the one I'm going to talk about in this video uses Python's built-in HTTPS server library to develop a web server with the Raspberry Pi and control the Raspberry Pi within your local area network. So let's jump right into it. What you're looking at now is kind of my version 1.0 of the web server that I have and designed thus far. So we have a couple different options to go over. So you can see the activity monitor here reads out the current CPU temperature of the rover. So as you refresh this page, you'll see that these numbers will change. The rover controls are here as well. So we have forward, backward, left, right, and stop. So these are hyperlink buttons that are clickable by the user. And what it will do is navigate towards the URL, your IP address /forward, and execute a certain command. And I'll get more into details with that in a second. Lastly, we have the obstacle avoidance program. As you saw in my previous videos, that program is designed to help the rover avoid obstacles in its path and move around freely without hitting obstacles. And I can start that program just right here. So the benefit of this web server is basically you don't need to connect a monitor to your Raspberry Pi or use a VNC server. If you want to test some small things out, you can open this web server and just use these rover controls here to test different motors if you want, or start the obstacle avoidance program. So the main resource that I use to develop this web server is from this eTinkers website, and basically they use this web server template to control the Raspberry Pi's GPIO pins to turn on an LED. And I highly recommend going through this website just to understand all the concepts that is involved with this server library. And basically what I did was use this template that they provided and uploaded it to my Raspberry Pi and modified it to make it my own. And as you can see, there's some of the typical things that you saw in previous code. The motor controller configuration for the RoboClaw motor controller itself. We have the classes and objects that are related to the server library. And once you get more advanced into this web server, you'll see how you can use the do head and do get more efficiently. But the most important thing I've been using right now is the HTML server, HTML block. And what I have here is, for those who are unfamiliar with the HTML code, it's basically a way to customize and make your own type of website. You can customize the width and the margin size of your website, and the title pages, the subtitles, and how you can center everything. And the main thing that I've been focusing on are the hyperlink buttons for the rover controls. So basically how that works is if you click the button forward, it will reroute the URL to /forward, so your IP address /forward. And when that /forward is active, it will execute a certain command, and you'll see those commands in a second. So it's a similar fashion for backward. So when you click backward, the URL will change to /backwards, and the same thing for left, right, stop, and the obstacle avoidance program. And so with that mix of HTML, you can also use Python to execute those certain commands. So when you click forward at the hyperlink forward button, your URL will change to your IP address /forward. And I've told it to, when it's /forward, to execute this command, which is using the RoboClaw motor controller to move all 6 motors in the forward direction. And similar in the backward, if it's /backwards or you click the backwards button, you'll move all the motors backwards. For the left and right rotate, for the left rotate, when it's left, the left side motors will go forward, the right side motors will go backwards, and it gives you that differential rotation going for the rover that you've seen in previous videos. In a similar fashion with stop, it can stop all the motors itself, and starting the obstacle avoidance program. So that's basically how the code works. This is all uploaded to my GitHub, and it's kind of a good mix of HTML and Python to get this web server going. So let's just jump right into a live demo that I have set up here to kind of give you a better idea of how quickly this web server can be initiated and how it can be utilized for the rover that I'm using now. So I have a live feed down here of the rover, and I can use the terminal command here to execute the Python script at this location. And once I click enter, the server starts, as you can see, at this IP address that I've currently blurred. And when I click forward on this web server here, you can see that the rover is moving now, and I can click stop. If you go backwards as well, as you can see, the rover is also moving backwards. I can press stop there. So as you can see, it's pretty responsive on, when I click the button, maybe there's a half a second delay when I click it and when the rover starts moving, but overall it's pretty responsive. And as you can see, the terminal window here shows you that it's receiving that /stop, and it's telling it to execute those commands related to /stop or /forward or /left right here, and or /backwards as well. So that's kind of the whole gist of this part of the project that I'm working on, using this web server to get some controlling this rover remotely, and using this HTML server library to control this rover remotely. So that's all for this video and this live demonstration. I hope you guys enjoyed it. In future videos, I will continue to improve the features on the rover and continue to improve the functionality of the web server itself. And people can use JavaScript and CSS to continue to customize it to however they want to. In future videos, I'll discuss different ways how you can use web servers with the Raspberry Pi. So thank you, stay tuned, and see you guys next time.